Dear students, my name is M. Sekhar. My subject is physics. Today, let us discuss our junior intermediate portion block on block concept, which is a mixed concept of Newton laws of motion and friction. That means in the case of block on block, that ground surface we can imagine that as smooth surface. There will be frictional force between block and block. Here there are two cases. Case number 1, force that is applied on lower block. Case number 2, that force can be applied on upper block. Now we shall discuss when force is applied on lower block, that different consequences. Now let us see that case number 1. That means the friction coefficient between two blocks is mu. Let F be the force applied on lower block. If we want to analyze that motion, that means force F is applied on lower block and bottom surface that is smooth. There will be friction between that upper block and lower block. In the case of that, for example, so this is a smooth surface, this is lower block, this is upper block. Coefficient of friction is mu, between these two blocks is mu. Here I can say force F, that is nothing but applied. As we consider, this is M1 and this is nothing but M2. Here there are two possibilities. Possibility number 1, these two blocks may move with same acceleration. Possibility 2, these two blocks may move with different accelerations. For example, if you want to calculate that one simple formula for acceleration, A that is equal to capital F by sum of these two blocks, M1 plus M2. First calculate that A, force by total mass of that system, M1 plus M2. A equals to F by M1 plus M2. After that, if you want to go for another simple calculation, for example, step number 2. For example, this is step number 1. That is A equal to mu G, where mu coefficient of friction, G is nothing but acceleration due to gravity. Now you have to compare this acceleration value with respect to this mu G value. For example, here A equal to F by M1 plus M2. Here let it be some A dash. A dash equal to mu G. Comparison, if you want to compare these two, that is A less than or equal to A dash. A value less than or equal to A dash. Then both blocks M1 and M2 move with the same acceleration, or I can say moves with the same acceleration. Therefore, A1 equal to A2. I repeat, if A less than or equal to A dash, then both blocks M1 and M2 moves with the same acceleration, small a1 equal to small a2. In the case of that, step number 2, comparison, first comparison that is completed, if A is greater than A dash, then both blocks will move with different acceleration, A1 not equal to A2. Then upper block will move with different acceleration backward with respect to lower block. That means that directions may changes, numerical value may changes. We should have to calculate that value. So A greater than A dash, A1 is not equal to A2. Now take one problem with different force values. I want to discuss with 3 cases. In the case of first one, F equals to 21 Newton. Next one, F equals to 35 Newton. F equals to 40 Newton. The coefficient of friction between two blocks mu is equal to 0.5. The numerical value of acceleration due to gravity g equal to 10 meter per second square. So this is the case. That means we have to analyze the motion of the blocks with various forces so that we can calculate that acceleration. Now, in the case of that first one, if I want to take, this is 5 kg, this is 2 kg, upper block 2 kg. As I said, this is smooth surface. Here coefficient of friction between these two blocks, that is mu equal to 0.5. Acceleration due to gravity g equal to 10 meter per second square. Now, in the case of that, case 1, first I want to take case 1. F equals to, let it be 21 Newton. Now, A equal to, acceleration A equal to F by m1 plus m2. Force applied, that is 21 Newton. Sum of these two blocks, that is 7. Then that value corresponds to 3 meters per second square. Now we have to calculate A dash. A dash equal to mu g. Mu, that is equal to 0.5. G equal to 10. 5 meter per second square. As we discussed, A value is less than A dash. That means A1 equal to A2. That is equal to this acceleration. That means 3 meters per second square. Therefore, upper block and lower block both are moving with same acceleration, 3 meters per second square. So this is nothing but case number 1. Now I want to consider in the case of case number 2. Just I want to take case number 2. That is, I want to change that force value equal to 35 Newton. Let it be case number 2. Here A equal to F by m1 plus m2. Here force value I can take, this is nothing but 35. This is equal to 5. A dash, that is same. A equal to A dash. In this case number 2, A equal to A dash. Here also both blocks moves with same acceleration as per the theory. Both blocks move with the same acceleration, which is equal to A equal to 5 meter per second square. That means we verified the second case also. Now let us go for case number 3, which is nothing but I want to take applied force. Applied force which is applied on that lower block. I want to take, that is case number 3. Let F equals to 40 Newton. Take this force F equals to 40 Newton. In the case of that, acceleration A equal to F by total mass, once again m1 plus m2, which is equal to 40 by 7. Ultimately this is more than 5. That means simply I can say more than 5 meter per second square. Whereas A dash equal to mu g, mu equal to 0.5, g equal to 10, we are able to get 5 meter per second square. Definitely A value is greater than A dash. In this case, both blocks are having different accelerations. A1 that is not equal to A2. By using that free body concept, we have to determine that individual accelerations. That is, in the case of that upper block, just I want to take that upper block individually. So this is nothing but 2 kg. Here, weight of that block, let it be 20 Newton. Normal reaction, let it be N naught. For example, if this block is able to move with acceleration here, for example, let it be some A2. Here, in the case of that acceleration A2, these two forces are said to be balanced. The frictional force, if I want to consider, let it be F, which is nothing but mu into normal reaction. Mu that is nothing but 0.5 and normal reaction that is nothing but 20. Hence I can write let it be 10 Newton. The maximum frictional force that can be taken as 10 Newton. In the case of that, if I want to go for that lower block, this is nothing but 5 kg. Here we are applying, let it be 40 Newton. In the case of that upper block, if this is the frictional force direction, in the case of lower block, we will consider opposite, just like action and reaction pair. Here you can take, let it be 10 Newton. Here, acceleration of that block for 5 kg, you can take A1. Therefore, 40 minus 10, that is equal to, this is nothing but 5 into, let it be A1. 30 equal to 5A1. A1 that is equal to 6 meter per second square. Whereas here in the case of that A2 value, frictional force by that mass, then frictional force that is nothing but 10. This is nothing but 2. We are able to get 5 meter per second square. This is 6 meter per second square. This is 5 meter per second square. Hence, that relative acceleration, which is nothing but A1 minus A2, 6 minus 5, 1 meter per second square. That means upper block will move with 1 meter per second square backward direction with respect to lower block. In this way, if A value is greater than A dash, we have to draw that free body diagram and we have to go for individual acceleration. Then we can analyze that motion of that blocks. Is it clear to you?